the way that the effects, and especially CGI, portrays planets and space in general, because they don't really reflect the way that cameras work or telescopes work, even.
Well, yeah, well, that's a good point. Yeah, I don't think anything's really. There are very few movies that really take into consideration how cameras and lenses work in the vacuum of space or in different atmospheric conditions.
Yeah, but, and here's where I'm going to ask you a question, and I'm going to put you on the spot here.
Here we go.
James, what do our eyes, cameras, and telescopes all have in common?
They need to take in light.
Yes, absolutely. Absolutely. They absorb light. And so flat earthers will often complain, right, that about the fact that they can't see stars in NASA images, right?
Of course. That's one of the things that they like to lean on.
Right. And moon landing deniers will also say the same thing. Like, why can't we see stars in the moon landing footage? Really, there's a simple answer for this. These people just don't understand how cameras work.
Pretty much.
So, scrolling through my notes right now, right? Because I do have notes. Obviously, when you're looking at the moon in these photos, the stars are there. They're just too faint. You can't see them in images, and there's a reason for that. If you were to take your cell phone camera out and try to take pictures of the night sky, you would have some fairly crappy results, right?
Oh yeah, I've tried with all kinds of phones throughout the years, and they never turn out good. I just stopped trying after a while.
Right. So, if you took that camera and you pointed it up at the night sky, you're probably just either you're going to see a really tiny dot if you pointed at the moon, or say Jupiter. Jupiter's fairly bright in the night sky. Or if your cell phone camera is really crappy, you're just going to see a black screen. So similarly, if you try to take a picture of someone standing in front of a bright window, you're just going to see a silhouette, despite the fact that your eyes can see so much more than that, right?
Yeah. Well, our eyes are meant to take in more detail than your average camera lens, I imagine.
Right. So these issues with cameras, they translate to space as well. In fact, there are three different things that probably matter most when dealing with cameras in general, but also in space as well. And one of those is camera sensitivity. The second thing is how much time your camera has to collect light. And the last thing is dynamic range that your camera has to function in dark and light environments. So the first point, sensitivity. That's pretty simple, right? How much light does your camera need to take clear images? Some cameras adjust sensitivity by opening and closing the aperture, something that the human eye also naturally does. And actually, you can, at home, do this as an experiment. Just go into the bathroom, take a light, and shine it directly into your eye, and notice that when your pupil starts shrinking or expanding, it's called dilating, that's basically what it's doing. That's what your camera does. When it needs more light, it expands, right? When your eyes need more light, they expand in the dark, right?